Sec, cosec and cot functions. In the past we've learned three trigonometric ratios to use on a right angle triangle. That is sine, cosine and tan. Well, sec, cosec and cot functions are all three more trigonometric ratios that we need to learn. So how are these related to a right angle triangle? Well, we know that if we labelled this triangle here, we'd label it as shown. And we are fully aware that sine theta is equal to the opposite divided by the hypotenuse. We're also aware that the cosine of theta is equal to the adjacent divided by the hypotenuse, and we know that the tan of theta is equal to the opposite divided by the adjacent. But what happens if instead of wanting O divided by H, what happens if we wanted H divided by O? How have we got from this line to this line? Well, if you think back to your laws of indices, we've actually found the reciprocal of OH, which means rising it to the power of -1. So if we've done that to the right hand side, we'll have to do that to the left hand side, which becomes 1 over sine theta. And 1 over sine theta is equal to the hypotenuse divided by the opposite. And we say that 1 divided by sine theta is equal to the cosec. So cosec of theta is equal to 1 divided by sine theta. And if we're to write it in the form like this, we'd have cosec of theta is equal to the hypotenuse divided by the opposite. And they're very similar for all three of the new trigonometric ratios. So we just discovered that cosec theta is the same as doing 1 divided by sine theta. If we were to look at sec theta and do exactly the same steps as we've just done, we'd find that it's equal to 1 over cos theta. And cot theta is obviously going to be 1 divided by tan theta. Another key little point here is to remember from core 1 that core 2, but tan theta is equal to sine theta divided by cosine theta. Therefore, cot theta, because it's 1 over, means it must be equal to cosine theta divided by sine theta. And these three new trigonometric ratios work with any right angle triangle. So sec theta is equal to 1 divided by cosine of theta, cosec of theta is equal to 1 divided by sine theta, and cot theta is equal to 1 divided by tan theta. And you need to remember these three new trigonometric ratios because they're going to come in very handy when we look at doing some more trig identities in core 3. Now, to calculate these on a calculator, you have to unfortunately use the sine, cosine and tan button because there is no sec, cosec and cot button on a calculator. You must also, of course, remember to check that you're using the right measurement system. So for the first two examples here, we're using degrees, and for the last one, we're using radians. Now, the easiest way to calculate what sec of 30 is to remember that sec is 1 over cos, so it's 1 over cos of 30 degrees. So on a calculator, 1 divided by cos of 30 is equal to 1.153 to 3 decimal places. To do cosec of 75, remember this is 1 over sine of theta, so that's 1 over sine of 75. So 1 divided by sine of 75, and you get the answer 1.035. And finally, For cot, remember we need to make sure that we set our calculator up in radians for this question, as we're working in radians. We now are going to write this as 1 divided by tan of 9 pi over 11, and that's equal to 1 divided by tan of 9 times pi divided by 11. Remember to close the bracket if you do it on a calculator, and that gives you minus 1.556. So this video has introduced you to three new trigonometric ratios, which are sec theta, which is 1 divided by cos theta, cosec of theta, which is equal to 1 divided by sine of theta, and cot theta, which is equal to 1 divided by tan theta. In the next video, we're going to look at how we can draw these three new trigonometric ratios as a graph.